Now, let's start with the routing part of this module. This module is on BGP as a routing protocol or inter-domain routing protocol. But before we get to BGP and its specifics, we will briefly look at the link state and distance vector algorithm, inter-domain versus intra-domain routing in the internet, and then we'll introduce BGP as an inter-domain routing protocol. Again, before all this, a brief recap on forwarding versus routing. We know that forwarding is a transfer of a packet from the input port of a router to an output port within the same router. And individual routers uses its forwarding table and the router's input ports, output ports, and switching fabric together implement the forwarding function. It's always implemented in the hardware. And the routing happens in the control plane. It computes the paths that the packets will follow. The routers talk among themselves using routing protocols to identify what could be the best path between a source and a destination. And other control plane functions include executing the routing protocols, responding to attached links, going up or down, and other management functions. The role of routing is that in an IP network is datagram based, and the functionality of the network layer is to take the packet from the source and move it closer to the destination hop by hop. So in this whole process, in this whole routing process, there is a concept on administrative aspects called autonomous systems. So if you imagine big internet, there are multiple internet service providers or operators, there are different vendors, etc. And moving a packet from a source to destination is not limited to one network. It is across networks. So there are two types of routing protocols, inter-domain routing protocol and intra-domain routing protocol. And there are two types of routing algorithms, link state routing algorithm and distance vector routing algorithm. Now, what these are, we will discuss in detail shortly. However, inter-domain routing is routing between two autonomous systems, and intra-domain routing is routing within a certain autonomous system. Now, if we take a look at link state routing algorithms, just to recap what the characteristics are, in a link state routing algorithm, each router describes itself and its interfaces directly to its directly connected routers, and each node broadcasts its link state packets to all the other nodes in the network. So this leads to the condition where every other router in the network, its interfaces and the networks they connect to. So every router has complete view of the network. And the algorithm that computes the least cost path in a link state algorithm is Dijkstra's algorithm. And because every node shares all information with the directly connected nodes, all nodes in the network have identical and complete view of the network. In the case of distance vector routing protocol, each router sends its neighbors a list of well-known networks along with its own distance to each of these networks. And it is distributed in the sense that once a node receives some information from its neighbor, it performs calculation based on the information that is disseminated by that neighbor in terms of how much distance would this particular router require to reach the networks that are advertised by the neighbor, and then distributes the result of that calculation to its other neighbors. So it is kind of iterative in the sense that whenever there is an update from one neighbor, it results in a calculation and probably a new best path or new least cost path that gets advertised to the neighbors in return. So the whole process is iterative until the point of time in the whole network where there is no further updates being exchanged between the routers. So it does not advertise the entire network topology. And that is distance vector routing algorithm. So to take an example, we have a network here, and let's take a look at what would be the views of R1 and R4 if the network were to implement link state algorithm versus if the network were to implement a distance vector algorithm. So in the case of R1, this is R1. If it implements a link state algorithm, we said that it will have a global view of the network. So it knows the presence, R1 knows the presence of R3, R1 knows the presence of R2, which are directly connected neighbors, but R1 also knows the presence of R4 in the network and the networks that each of these connect to. And R4 in return also knows the presence of R3, R1 and R2 and the kind of networks it connects to, because in the link state algorithm, it is the global view of the network that from each router's perspective that is exchanged between the neighbors. Now, in the case of distance vector, there is no global view of the network. It has information only about its directly connected neighbors and the networks that we can reach from that neighbors. So, same example, the same network, but in the case of distance vector, R1 will see the network, the whole network as this. There is R1 only knows that from a serial interface 1/1, it will be able to reach 10.030/24 and 10.040/24. It will be able to reach 10.020/24 via serial interface 1/0. That is all it knows and the cost to reach those links. It is agnostic to the presence of R2 or R4 or R3 in the network. Similarly, how does R4 see the network? R4 knows that through serial interface 1/0, it will be able to reach all these three networks, which the link cost. So this is the difference in the views of the different routers that form part of a network when they implement the link state algorithm versus the distance vector algorithm. Now, internet routing protocols are of, we said two types, but there's also a third type here. There is a path vector type. So we'll look at these properties in terms of information dissemination. Link state algorithm flood the link state advertisements to all the routers. If you look at OSPF as a link state algorithm, there will be multiple messages that flood link state advertisements to all the routers. Whereas in the case of distance vector algorithm, it updates distances from the neighbor's distances, and then it's the routing table, the new routes that are propagated through the network. And in the case of path vector, it updates paths based on neighbors' paths. In terms of algorithm, link state implements Dijkstra's shortest path, distance vector implements Bellman-Ford shortest path, and path vector also makes use of local policy to rank paths and find out which one would be the best path for reaching a particular network. In terms of convergence, link state is said to be fast due to flooding, and distance vector is said to be slow, especially because there is a possibility of count-to-infinity problem. And path vector is also said to be slow because of path exploration. Examples of protocols that implement link state algorithm, OSPF and ISIS, distance vector algorithm, RIP or EIGRP, and path vector algorithm is BGP. Now, with that background, let's take a look at inter-domain versus intra-domain routing in the internet. We briefly mentioned that intra-domain routing is routing within an autonomous system. Now, what is an autonomous system? Autonomous system is an actual entity that participates in routing. For example, if you consider Airtel or Vodafone, they will have their own networks and big networks, and they'll subdivide these networks into manageable entities. It's a logical entity. And each entity, each set of routers, so let's say a small network within the entire subset of networks could be called an autonomous system. All devices or all equipments within an autonomous system are managed by a single operator. And it actually participates in routing. So it has each AS or each autonomous system has a unique identifier. It used to be 16-bit, but I think with RFC 4893, it is now 32-bit ASN number for each autonomous system. Examples are for Sprint 1239, 1240. These are ASN numbers that are assigned to Sprint autonomous systems. Autonomous systems belonging to AT&T are assigned numbers like 7018, 6341, 5074, etc. So it is well-known numbers. They are allocated by a central agency. So that's the concept of autonomous system, and intra-domain routing refers to routing that happens within an autonomous system. Now, there is a difference between the routing that happens within an AS versus the routing that happens between ASs, autonomous systems, because one AS is controlled by one management entity. Another AS could be controlled by another management entity. And if you have to implement inter-domain routing between autonomous systems, then has to be some sort of agreements between these two autonomous systems. So examples of intra-domain routing are OSPF and RIP. And examples of inter-domain routing, which is between autonomous systems, are BGP, which are like policy-based path vector routing protocols. And these also take care of implementing routing policies based on business agreements or relationships. If we take a look at high-level view of how the ISPs are connected together in the entire internet, we have multiple tiers. At the lowest level, we have the access ISPs. This is just to give a perspective before we start talking about BGP. There is an access ISP which provides wired or wireless connectivity, for example, DSL or DOCSIS or cellular networks. And the multiple access ISPs, these access ISPs connect to what are called regional ISPs. So the next level of ISP in the hierarchy is regional ISPs. And regional ISPs connect to Tier 1 ISPs. There are approximately 12 Tier 1 ISPs, including AT&T, Sprint, NTT, etc. And the access ISPs, in terms of who pays who, nothing comes free. In terms of who pays who, access ISPs pay the regional ISP for providing the backhaul connection between these access ISPs, and regional ISPs in turn pays the Tier 1 ISPs for enabling the larger internet. So if the access ISPs were not there, the network would still be there, but it will be limited to whatever is reachable by the access ISPs. So the larger interconnection of networks or the larger interconnection of ISPs is made possible by regional ISPs, and at a yet higher level, it is made possible by Tier 1 ISPs. with that background, inter-domain routing in the internet, for achieving inter-domain routing in the internet, do we choose link state or distance vector? Now, the considerations for choosing an inter-domain routing protocol in the internet would be scalability. The protocol should be able to scale up to the millions of connected devices in the internet. Stability, we should not end in cases where paths are not stable, the protocol is not stable, and there is a loss of network connection. There should not be routing loops created, because the scale at which the protocol has to operate will be in terms of millions of connected devices. And also how fast the protocols react to change. For example, if a link goes down, it shouldn't take eternity for the routing protocols to establish an alternate path. So we have seen that there are problems with distance vector algorithm in terms of convergence, and problems with link state routing protocols in terms of the database becoming too large because of the global view of the network. So it's not a right kind of protocol to be used for the entire internet. And there is also not much of support for routing protocols that implement link state algorithms like OSPF. So therefore, the best suited protocol for inter-domain routing in the internet is distance vector with path, or path vector algorithm, path vector protocols, where each routing update carries the entire path to its neighbor. And when an autonomous system gets a route, it checks if the autonomous system is already there in the path. If it is there, it discards the route, and if it is not there, then it adds itself to the route and advertises the route further. So this is only a high level of what's going to come next. Distance vector with path, or path vector algorithm, is what is commonly used for inter-domain routing, and the most popular protocol in that segment is Border Gateway Protocol, or BGP, which is a policy-based routing protocol. Relatively simple protocol, but the configuration is complex. However, the advantage with complex configuration is that you get to play around with policies and different other things in such a manner that it enables smooth conversations between AS in terms of protocol, in terms of exchange of information. So these are some of the references for BGP. BGP4 is the one that we'll be referring to, RFC 4271. And the next one that would be relevant as additional reading would be MPBGP, or multi-protocol extensions to BGP. So in this video, what we looked at was briefly recapped on link state algorithm versus distance vector algorithm. We looked at the difference between inter-domain and intra-domain routing in the internet. And we also introduced BGP4 as the inter-domain routing protocol, which is the most popular routing protocol for the internet.